Good morning students. So in this class we are going to discuss about impulse. So if a very large force acts on an object for very short duration, a large force acts on an object for very short duration, so force is called impulse. So using Newton's second law, so force is equal to rate of change of momentum. Just rewrite. So a strong force, a large force acting for a very short interval of time. So F dt is equal to dp. So the time is somewhat very small. So we need to integrate. So integral dp, then integral F dt. So that is the momentum changes from initial to final. Then the force acts for a small time, that is initial, t initial, then t final. So integral dp equal to p, so initial to final. So then substitute that final, that is upper limit minus lower limit, so p final minus p initial. So the momentum of an object at time t final, the momentum of an object at time initial time, then f, the integral dt equal to t. So again the same, upper limit minus lower limit, so that pf minus pi is a change in momentum, that is delta p. So the time, final time minus initial time, that is delta t. So delta p equal to f delta t. So the impulse j is equal to integral, that's initial time to final time, force into dt. It's also called change in momentum. So a strong force acting for a very small interval of time, that is impulse. So that is also equal to the change in momentum. If a force is constant over a time interval, so the force, the given force is constant over a time interval, then f delta t equal to delta p. So this is a momentum, impulse momentum equation. So you can write it in terms of average force. So average force acting on an object for very short interval of time, the change in momentum. So f average equal to delta p by delta t. So if the average force is greater if delta t is smaller, because force is inversely proportional to here time. So the time is, the average force is very high if the time is very small. So at that time the change in momentum, so the momentum changes very quickly. So we can write it in terms of impulse in terms of f average. So j is equal to f average into delta t. So this is a two graph. So a constant force acting for a time t, here a variable force. See the x axis is time, the y axis is force. So a constant force acts from initial to final. So the force value is constant. So this is a f average. So the impulse j is equal to f into delta t. If it is a variable force, see the value of force at time initial, so it changes, keep on changes, it reaches a maximum, again keep on decreasing, so it reaches the 0. So here, so at the initial time to final time, so the force, that is variable force, so this is the f average, so the peak, f peak. So for the impulse j is equal to integral t initial to final f dt. So if it is for constant force, j is equal to f delta t. If it is a variable force, integral initial time to final time f dt. So in this class we have discussed what is meant by impulse, that is a very large force acting on an object for very short duration, that is j is equal to integral f dt. So okay students,